velocity of N2. Okay, so let's go first with R1 is equivalent to, this is R1 and 2 is equivalent to, what is this one? 0.5 meters per seconds. Now, in order to get this one, no, in order to get the diffusion of these two, okay, or the molecular mass of that one, we have to find first the atomic mass of nitrogen. And what is the atomic mass of the nitrogen? Hmm? Can you check in your book, the one in front? What is the atomic mass of nitrogen? Anyone from the group? Nitrogen has what? Atomic number 7. And what is the atomic mass? 14.01. Very good. Okay, thank you so much for those who answered in the chat box. Okay, so let's put it 14 so that no need to have the point something, so that it will be easy for you already. 14 times how many atoms here? Times 2. So it will be 14 times 2, that will be 28 grams per mole. Okay, that will be the unit already. What about this one? Carbon. What is the atomic mass of the carbon? Atomic mass of carbon is 12.01. So let's use the 12 times how many atoms? We have 2 also. Then that is equivalent to how many? 12 times 2 is 20, 24 grams per mole. Now, we are already complete. Okay? The question is, find the rate of diffusion of carbon gas if nitrogen gas diffuses in 0.5 meters per second. So what we will do, we're looking for the rate of velocity for the C sub 2. So this is the what? Okay, this is what? The unknown. Okay, now try to look at this two. Here we have 28 grams, and here we have the 24 grams, which is lighter and which is heavier from these two. Okay, which is lighter from the two? Is it N2 or the C2? Huh? The C2 is the lighter one. Very good. And the heavier one is the 28 grams. So let's compute already. From the given formula a while ago, R sub 1 is equivalent to square root of molecular mass 1 is equivalent to R sub 2 is equivalent times the mm sub 2. Okay. Now, since we're looking for, what's the one that we're looking? The R2. Okay? We're looking for the R2, correct? Okay? So what we will do this time is to derive the formula. So what will be the formula for this one? What's the formula? Since we're looking for the R2, so that will be, hello mga kapatid, what's the formula? You can tell. Can I try? Yes, who's that one? Mackenzie. So
Hello, sir.
R2, yeah,
Can you
hello.
hear me?
Yes, my dear.
Uh, R1 square root of molecular. Sir, it's molecular mass, right? Just to
Yes,
be
my
sure.
dear.
Okay. Molecular mass sub 1 all over the square root of molecular mass sub 2.
Okay, very good. Just wait, ha? Okay. Okay, back to the ball game. So, according to Mackenzie, R1 times square root of molecular mass 1 over square root of molecular mass 2. So, let's substitute already the value. Is it clear, pictures, teachers, students? Is it clear, the one that I'm writing here? Is it clear to you? And hey, is it clear? Huh?
Sir,
You're like the dog in the FX. You're just doing that one. Okay, you answer me. You answer. So let's substitute. What is our R1? Okay, R1 is the gas one that is lighter. So meaning to say that will be 0.5, okay, meters per seconds multiply with what is our MM1? Hmm? That will be MM1. What is that one? 28. Is it the 28 grams? Yeah, that is NN2. Okay. It's, please wait. 28 grams per modi. Okay. Sorry, this is a square root. Okay. Then all over, what is that one? The MM2 is 20, 24. Ay, not good my handwriting. Grams per mole. And that will be square root. Okay, cancel this one, cancel this one. You have to square first this one. Or if you want continuous already, do the operation. Then, what will be the answer for R2? Go and so compute. Yes, John Marlon. What's the question? You have question, John Marlon?
sir, may I ask po,
Yes, Abby.
the MM1 po, is that po the lighter
Yeah,
molecular mass?
going back to the this wait going back to this presentation, we said that MM1 is the lighter molecular mass. So it seems inverted. Correct? It
Yes,
should
sir.
be 24 the upper part. Yeah. Okay. I noticed also that one. Okay. So it will be like this. 0.5 meters this way per seconds multiply with square root of what is this one? 24 grams per mole all over square root of 28 grams per mole. So we need to cancel this part. Okay. This part also. I don't have pentel pen anymore. So let's compute this one. 0.5, okay, times the square root of 24 divided by square root of 28. It seems that in my part, my camera is a bit blurred, promise. In your part, it's not. It's clear.
Sir, it's readable po, but it's not that focused po.
Okay, this way. There. What about this one? It's fine. Still the same.
Still the same po.
It should be. If it is like this, it's fine. Or still the same. My God. But it's
Maybe,
readable.
yes po, I think we can identify naman the numbers.
Okay. Because as I can see, it seems not. Okay. So let's compute. A little blurred po. So, okay, I'll check this one. Mhm. Okay, so you can compute 0.5 times square root of 24 degrees, 24 degrees, 20, square root of 24, then divided by square root of 28 degrees. You can type your answer in the chat box, my dear. 1.06 meters per second. So according to Denzel, let's wait for the others. So square root of 24 times 0.5 divided by square root of 28. Okay. Okay. Then the correct answer is what? How did you get the 1.06 meter? Denzel. So I hope it's visible because upon checking 0.5 times square root of 24 divided by square root of 28, then the answer is 0. Please wait. Again. 0.5 times 24. Okay. Square root of 24 divided by square root of 28. Okay. Then the correct answer is 0.46. Okay. 0.46 meters per seconds is the rate of the number 2. Okay. So gets already? Okay. Now let's try another problem. Okay. Let us answer for the number 2. Okay. For the number 2, find the rate of the diffusion of the oxygen gas if it was sealed together with the chlorine gas in a tanker. Note that the chlorine gas diffuses at a rate of 2 meters per second. So you'll be the one to answer first. Then later on, I'm going to show you how to get the answer. So remember, you check first which is the lighter molecular gas and the heavier molecular gas. Okay. You may proceed, Jody. You can type your answer in the chat box if you're done. Waiting for your answer in the chat box, guys. I can see some answer. 1.34, 1.39. Let us see. What is the correct answer? I'm waiting for the others. What about your answer, my dear people of the Philippines? Okay, so let us compute with this problem. According to this problem, find the rate of diffusion of oxygen gas if it is or if it was sealed together with the chlorine gas in a tanker. Note that the Cl gas or the Cl or the chlorine gas, okay, diffuses at a rate of 2 meters per second. So what are the given? We have the Cl2 or the Cl gas, promise, because in my part, I can see that it's a bit blurred my camera. Okay? Anyway, I'm going to fix this one. Then we have the oxygen gas. So what is the uh, molecular atomic mass of our Cl or chlorine? What's the atomic mass of the chlorine? 35.6. 45. Did you use 35.45? Okay. So 35.45 times how many atoms? 2. Then we have here oxygen, 35 only. Okay. So let us use 35. Okay. You just use the whole number, guys. So 35 times 2, that will be how many? 70. Okay. Then what is the atomic mass of oxygen gas? We have 16. 16 times 2, that is equivalent to 32 grams per mole. So which is heavier? This is the heavier, no? And this is the lighter one. So the Cl2 has this what is this one? Cl2 has this 2 meters, no? So R is equivalent to Cl sub 2 is equivalent to 2 meters per second. So as you can see, since Cl2 is the rate or R2, because remember in the given, going back here, R2 is the slower rate speed gas or the gas 2. So the slower rate here is this Cl2 because that is the heaviest one. So we're going to find the R1. Okay? So let's proceed already with our given. So what's the formula this time? So if we're going to get the R1, ang labo talaga ng camera ko, nainis ako. R1 is, what's the formula for R1? R1 is equivalent to,
Sure, I try po.
go Abby,
R sub 1 times molecular M sub 2 over square root of M sub 2 over square root of M sub 1.
it's R sub 2. So R sub 2 no, is equivalent to or square multiply to square root of molecular 2. Okay. All over the square root of M1. Okay, let's substitute. So we have 2 meters per second multiply to square root of what is MM2? We have 70, correct, grams per mole. Okay, all over our MM1, we have 32 grams per mole. We have to square root this one, cancel. Then what will be our R1? Miss, may camera. Okay, what's your answer? There, Carly, 2.96 meters per second. Very good. So 2 times square root of 70 divided by square root of 32. Then the answer is 2.96 meters per second. Okay, meters per second. So this is the value of R1. Yes, are you following? Huh? Okay, very easy, no? Then, last one. Let us have another problem before we proceed with the Graham's law. Okay, try to answer this one. Compare the rate of diffusion of helium gas and carbon dioxide. If carbon dioxide diffuse for 1.25 liters in a second. Teacher, there will be carbon dioxide. So meaning to say you need to get the molecular mass of carbon and then the oxygen. Then you have to add that one. Then that will be their weight, no, of that carbon dioxide. You know what I mean? Okay, go. Let us try later. Let us see who can follow. Yes, Nathaniel, just get the whole number. But for example, if it is rounded already to the nearest whole number or rounded to the nearest number or whole number, then do it. For example, let us see. Carbon. Carbon is 12. So 12 still. Oxygen is 16. 16 still. Helium is equivalent to, what's the value of helium? He. 4. So still, no? You get the whole number only. Okay? So there. So I'm going to give you how to compute this carbon dioxide. So we have carbon, that is 1. Of course, automatic there will be 1. Then oxygen, we have 2. So here carbon, that will be 12 times 1. And here is 16 times 2. Okay? So compute for that one, that will be 12. And the other one is 32. Then that will be 44 grams per mole. So this will be CO2. So this will be the value. Okay? Did you get, are we the same answer with this one? Okay, very good. So compute. The other one, it's easy already, that one. Again, if you're done, you can type your answer in the chat box, guys. Don't forget the unit. Yes, Mackenzie, what is that problem? We're
Um,
confused in one part.
Hello, sir.
Yes.
For the last part, right? The last part, we are finding R1. How would you know which R you're finding? Because it's confusing me a little bit.
bad trip. I keep on talking since a while ago. So, if you will notice, no, for the heavier molecular mass, of course, the speed of that one is this slower rate. So that will be R2. And then if you are the lighter one, then you are faster than the R2. So that's the one. That's why I color it blue to blue. I don't know what's the color. Is it blue? Or some blue-green, no? R1 and M1 are together and R2 and M2 are together. That's the one. Okay? So going back to the problem, number 3. So here we go. So did you compute already for the helium gas? Huh? Let us try. So let's go already with our helium gas. So helium gas is equivalent to what value? Helium gas has the molecular or the atomic mass of 4.0 or 4 times 2. So this will be 8 grams per mole. Okay? So what's the other answer? So as you can see, here you will determine already which is MM1 and MM2. Okay? Because you will notice already with this value. So which is heavier here? Is it the carbon dioxide or the helium? So heavier is which is heavier? Carbon dioxide. So this will now be your MM2 and this one will be your MM1. Okay? Now, according to the given, we have if carbon dioxide can diffuse for 1.25. So this is the rate of the carbon, 1.25. So carbon has 1.25 meters per second. So going back to this part, okay? So going back here, ha? So look at this one. Since this is the heavier one, okay, here MM2, the heavier one. So meaning to say that is R2. This value now is your R2. Okay? I'm using big letter, sorry. No, it should be small letter R. Okay, gets? So now, here, the fastest one, since this is the lighter one, so we're looking for R1. Okay? You get the point? Huh? Are you getting this one? So now, the unknown is R1. Okay? And what is the formula for R1? Just like the formula a while ago, we have R1 multiply to square root of R1, R2. R2 multiply to square root of MM2 all over the square root of MM1. Okay? Are you following? Now, let's proceed already. Let's compute or let's substitute. What is R2? Huh? R2 is 1.25 meters per second multiply with the square root of what is MM2? That will be 44 grams per mole all over square root of what is that? The MM1, 8 grams per mole. Okay? So what we will do now is to cancel the unit. So compute for R1. Then R1 is equivalent to what? Okay, I love calculator. For those who have calculator, what's the answer? Huh? Then the answer is it 4.15 or 2.93? Okay, the answer is 2.93 meters per seconds. Oh, sorry. That will be our R1. Okay? Question? I think I don't have any more the problem here. Do I have still? Just wait. Okay, that's the last already. Okay. So that's the end of the session for the Graham's law of effusion and diffusion of gas. Okay. Now, for your let's wait, changing the camera. For your Graham's law, you will just watch a video, no, because this will be very easy. You will just add this one, eh. P1 plus P2 plus P3 is equivalent to partial pressure. So allow me to present this one, okay, for a while. Partial pressure.
Dalton's law of partial pressure will be easily explained in this video with animation. Let's say we have a container with three different gases. Gas 1, gas 2, and gas 3. Note that the gases are all inside the same container. This means that they all have the same volume. Now let's take the same container and spread the gases out equally while holding the volume constant in each container. The sum of the partial pressures of the three gases will equal the total pressure of the mixture of gases. Let's look at the pressure meters above the gas chambers to notice that each partial pressure of the individual gases equals the pressure of all the gases in the same container. Now let's look at the formula for Dalton's law of partial pressure. First, let's derive the ideal gas law, where pressure times volume equals nRT. We can see that the pressure is equal to nRT over V. Now let's look at Dalton's law of partial pressure, where at a constant volume, we can add the partial pressure volumes of the individual gases to equal the total pressure of the combined gases. Let's do a sample question here. A gas mixture contains hydrogen, helium, neon, and argon. The total pressure of the mixture is 93.6 kilopascals. The partial pressures of helium, neon, and argon are 15.4 kilopascals, 24.7 kPa, and 35.6 kPa respectively. What is the pressure extended by hydrogen? So we know that the total pressure is equal to 93.6 kilopascals of pressure, and we have the pressures of the other three gases in the mixture. We also know that all the units are the same, and we don't have to do any mole conversions. So all we need to do is add up the three individual pressures and subtract them from the total to get the pressure of hydrogen, which is 16.9 kilopascals. This question uses Dalton's law of partial pressures perfectly. Thanks for watching. We hope you
Okay, is it clear to you? Now, going back to this problem, as you can see, no, this is only an example. What if the problem is like this? A gas mixture contain hydrogen, helium, neon, and argon. So, imagine that the total pressure is not presented. The partial pressure of helium, neon, and argon and hydrogen are the following. So, we have 15.4 kPa, 25.7 kPa, 35.6 kPa, and 16.9 kPa. The question is, find the total pressure of the mixtures. So if that is the case, what you will do is to add only those gas 1, gas 2, or the gas of neon, the gas of helium, the argon, and gas of hydrogen. Now, can you compute those gas? So if you will compute these things, we have 15.4 plus 25.7 plus 35.6 plus 16.9. Then the answer is, what is the answer? Is it correct, the total pressure? Okay, so the correct answer is 93.6 kilopascal. So only that one you will just add. Okay? Question? None? Is it clear? Okay. Don't worry, we'll just focusing on the Boy's Law, Charles Law, Guy Lussac's. Only few. Okay? It's very easy, this Dalton partial pressure. Okay? So, expect the unexpected. Next week, you will have your quiz regarding this matter that we discussed. Okay? If you have some questions or problems, please let me know so that I can teach you and let's have the remedial class. No? Because by next week, what we will do is to have the balancing already. Okay? So, I think it's already time. It's already 11:50. I can see that some of the 10A are off the camera. What happened, guys? Huh? Please turn on your camera. Okay? You're sleeping already. So, let's get it on. Who's our prayer leader? Prayer leader. Eric Jacob. Ah, yeah. This way. Thank you so much, Aldea, for later. Don't worry. Okay? Proceed.
In the name of the Father, the Son, and the Holy Spirit. Bless us, O Lord, and kiss thy gifts, in which we are about to receive from thy bounty, to Christ our Lord. Amen.
In the name of the Father, the Son, the Holy Spirit. Amen. Thank you so much. 10A. God bless everyone and enjoy your weekend. Okay? For the different